Good morning to all. I am Poongoli from IT Department, Sri Shanmugha College of Engineering and Technology. So today we are going to discuss about the domain is data structure and algorithm, and the topic is deletion of node in a list. And let's begin the deletion of node in a list. First, deletion at first position. When the operation performs removing of first element in the existing list algorithm. Take existing linked list as input. Then enter the position of node which we want to delete. And in first position, checklist is empty. If empty, print empty list. Else, del node as head. And head is equal to del node, that means next. Free del node. Deleting first element. Here, deleting first element C from the existing layer. So we have one list. So that is one head is here and one D node is here and C is here. So here we have to delete the first element delete C from existing list. So delete node is equal to head. So that means C as a head node. So we have to delete here. Head node is equal to delete node, that means next. Automatically D as a head node. So next, that means the C should be deleted here. C should be deleted here and D is a head. And this is the deleting from first C. See, we have to delete C from the existing list. Okay, and similarly deleting first element A from existing list. Already we have one list. This is, we are here 1 field, 2 field, 3 fields. 3 fields we are having. Each field has 2 nodes. So that means here A as a head node. Okay, and C is one node and D is also another node. Okay, another field. And here we have to delete A. So if delete A means, automatically C as a head. So del node is equal to head. Here A is a head node. This is the delete node. So head node as a delete, so automatically next as a head. So what is the head? C is a head. So here A is deleted, so and C as a head. Okay, so and C code, pseudocode for deletion at first position. And here, so void deletion first, and if head is null, that means it's not empty. That means it's not empty. So del node as a head, that means head as a del node means it's automatically next as a head. So here free del node. So that means else print of empty list. And deletion at middle position means here. So this is one kind of operation. This operation performance removing of middle element in existing list algorithm. So take existing simply list and enter the position of node which we want to delete. Position of node. And if middle position, enter which data want to be deleted. And find the position of del data and assign it current to pointer and its previous pointer. Assign del node is equal to current, the previous next del node is equal to next, then print del node. Here we have to delete B, middle letter elements. So here three fields we have, one is A and one is B and one is C. We have to delete B only. So delete B only, we have to delete. So that is current is head. So current is automatically A is head here. And next, while current data it's del data, that means previous is a current data. This is the previous and current is next. So automatically this is the current data, we have to delete in the B element only. So now del node is a current node. So this is the del node now. So B is a del node now. Then this is the pointer here. We have to delete the middle node B. So automatically this node is delete here, and this is the first node and this is the automatically next node. The address should be changed here. The address automatically change here to this here. And this is the pseudocode deletion at middle position. First consider void deletion middle and void deletion middle. So printf enter data to be deleted and scanf get percentage d modulus d as a del data. It's the current is equal to head. That means while current is data and data del data. So previous is equal to current. Current is equal to next. And this is current, current next. And del node is equal to current and previous next node is equal to delete node. Next automatically delete node is a free node. And the deletion at last position. The operation performs removing of last element in existing list. Take existing singly linked list, enter the position of node which want to delete. If last position, find the position of last node in the list and assign it to current pointer, previous next null. So delete node is equal to current, automatically pre-delete node. Delete last node. Delete last node. So if you want to delete last node, here last node is C. So that means here we are going to delete the last node. Delete C node, we have to going to delete the C node. So that means A is a current node here. Fix A is a current node. Next, A automatically previous node. And which node is we are going to delete? That is as a current node. Which node we are delete? That is node as a current node. And this is the current node. So if the node is that we have to delete, that means automatically the next field of B it's a null node. It comes. Okay. This is point and this is the final output of if the node is last as C, that means that node should be deleted. That means automatically the node should be get deleted and the B is the last node here and the last field is as null. And the pseudocode for deletion at last position means void as usual deletion last and current is equal to head. While current is next and null. So previous current. So current is also current to the next. And next previous is the next, that is null. So and del node is a current node. That means O of 1. And free delete node. Lastly, delete node should be deleted here. And this is O of n. That's next. Find operation returns the address of given element in existing list. Here itself also take existing single list, enter the element of node which want to find and traverse node in a list until the element encounter. By assigning current to head, move current pointer if current data is not equal to given element. Set previous pointer and next display current data and previous nextest location of the current data. And find B in the list. Already we have one existing list. We have to find B. So this is A is a current node. And this is written B in a position but 10. And this is pseudocode for find and void find. Print enter the data to find and also scan get the data, that is target element. And this is O of n and this is current is equal to head. And next, while current data it's a target element and previous data is equal to current, and as usually current is equal to current to the next. The printer in the modulus d in the location, the current is the data previous. And this is the finally traverse. And three types: deleting a node, find a node, and traverse. So we display all the element in the list. That is, first as usual take existing single list and traverse all the node in the list by assigning current to head. Move current pointer if current next and not equal to given null. So print all the data one by one. And this is traverse all the node in a list. That means this is the head. A as a head and A is a current node. And next B is a current node. C is a current node. So output is equal to A, B, C. That means this traverse all nodes. That means the entire A, B, C. All nodes can traverse all the elements. So while traversing, current is equal to head. While current next is equal to null, OFN, print up the current is equal to data, current is equal to next. And void is empty. That means if head is equal to null, double equal to null, printf is list is also empty. And OFN. And this is last. The time complexity is of for various operations that can be performed on the list of data structure. If create a node, that means O of 1, and if you create a list, that means O of n. So insert operation or delete, insert operation or delete operation. That means in first O of 1, in last that means O of n, because this is finite. We know the first element, and if we don't know last element also, that is let consider O of n, and in middle element also we consider O of n. The traverse operation should define O of n. So this is kind of operation. So and this are all the basic structure of and the functions of the deletion of operation and find the element and deletion operation. So then again I said that is if the considerers create a node means that is O of 1 and create a list means O of n. If first node means that is the finite value, that is O of 1, and if the last node means that is O of n, and middle it's also O of n. So that's all. This is the kind operation for the list, insertion, deletion, and find and traverse operations. That's all. Thank you. Thank you.